Hi guys, it's Maths for Everyone, and today we're going to do trigonometric functions. So let's have a look at trigonometric ratios of any angle. Now, angles of any size can be best explained using a unit circle. Now, unit circle is a unit circle, so it's a one unit circle. Now, that means a circle with radius of 1. So it's y, axis, 1, 1, minus 1, minus 1. And that is your unit circle. Now, all the radius coming from here is 1 unit, okay? So that's what it is. Now, another thing we need to know about is we're starting to use degrees here. So it starts from positive x-axis going anti-clockwise, okay? So don't get confused with bearings, okay? So it's going from here, and then so that'll be 90 degrees, and then 180, and 270, and back to 360 with a 0 where we started, okay? So that's where we start. Now, what happens if it changes the directions? If it goes to clockwise, what happens to clockwise? So if it goes to clockwise, still we starts from positive x-axis as our 0 and going to this way. So it's going to be negative 90 because it changed the direction. And then minus 180, minus 270, and back to minus 360 degrees. So that's what happens, okay? So that's unit circle. So when it comes to unit circle, going to anti-clockwise is a positive and the clockwise is a negative. Now, let's have a look at, I'm just going to keep it as a positive here. So I'm going to put it back to positive, 90, 180, 270, back to 360. Obviously, you can go past the 360, but I'm just going to stay with the 360 at this point. Now, if there was a point on the the unit circle, point P on here, and that's theta here, it's gone up there to theta here. And then what's the coordinates for P? Let's say it's X and Y, okay? So that's P. Now, this P is going to travel all the way back to fourth quadrant. So at the moment, it's the first quadrant. It's going to travel to second quadrant and third and fourth. It's reflecting, okay? So we will do that in a minute, but let's have a look at this one. And we are going to change this x and y coordinates in terms of trig ratios. Now, so far we know 3 trig ratios. What are they? It's a sine, cos, tan, okay? I'm going to change this x and y in terms of trig ratios. So what do we need to change it to trig ratios? We need right angle triangle and the theta. So we got the theta, and if I sort of put it in like this, I can see right angle triangle already. So that's right angle there, and that's what? That's my x and that's my y, isn't it? Okay, so I'm going to put this triangle here so that it's clear for us to see, okay? Now, what was this? That's my x, isn't it? The length of the base of this right angle triangle is my x, and the height of this right angle triangle is my y. And because it's a unit circle, my radius is automatically 1, okay? So that's my right angle triangle right there. So let's have a look at in terms of sine, cos, tan. Now, right angle triangle, sine, cos, tan is, what is it? SOHCAHTOA. We're going to use SOHCAHTOA, yeah? SOHCAHTOA. Now, before I use SOHCAHTOA, I have to label the all the sides. So that's my hypotenuse, and that's my opposite, and the line with the 2 angles, my adjacent. All right, so my sine theta equals O over H, which is O over H, Y over 1. Okay, so therefore, my Y equals sine theta. Okay, that's not too bad. And what about cos theta? Cos is A over H, A over H, so that will be x over 1. Therefore, my x equals cos theta. Now, I have already got x coordinates and y coordinates in terms of trig ratios. What is it? X is my cosine theta, y is my sine theta. So here, I can change this one to, say, P is cos theta and sine theta. Now, there's one more trig ratio that we forgot about. It's tan. So I'm going to put tan theta equals O over A. O over A is y over x. Now, of course, y over x we can also change into sine theta over cos theta, because y is sine theta, x is cos theta. So this is actually your very first trig identity. So tan theta equals sine theta over cos theta. Okay, so remember that. Excellent. So we got that far. Now, I'm just going to rub this one off. Let's have a look. If P is traveling to the second quadrant, like reflected, so it's here. I'm going to say P dash because it's reflected. So therefore, theta is still same because it's still same P, really. But what happens, I'm just going to get rid of all these so that it's easier to concentrate on one spot here. Okay, so now the P traveled to the second quadrant. Okay, it's a P dash. And coordinates will be minus x and y because that's negative x-axis, that's positive y-axis. Now, what is my angle from here to here? Now, remember, the angle starts from positive x-axis. It always starts from here to there, okay? So, what will be the angle of this? That is 180 take away theta, isn't it? Because that's a straight line, that's 180, and that's theta. So, the other part will be 180 take away that theta, okay? So, any line that, or angles on the second quadrant, how do we find the theta value? It is 180 take away theta, okay? So, that's okay. But what happens if it travels to P dash dash into third quadrant now? Third quadrant. So what happens now if it's in the third quadrant? So let's see. It's good that it's in the whiteboard so I can actually clear up a little bit better. So now it's theta here and we're going from here to all the way to P dash dash. Okay? So also P dash dash coordinates will be minus x and minus y. Okay? Oh, not a problem. Now from here to here, how do we find the theta? From here to here is 180 and then it's got extra theta there. So I can find the size of the theta, the whole thing here equals plus theta. Okay? So anything on the third quadrant, how are we going to find the value of the angle from the 0 to all the way? It's 180 plus theta. That's not too bad. Now, what happens if this one moves to, P moves to fourth quadrant? I'm going to call it P dash dash dash. Okay? And also it's going to x minus y. Alright? And the theta will be still the same. Okay, that's not a problem. And it goes from here to all the way to P dash dash dash. Okay? So how do we find this size, this angle? It'll be 360 minus theta, because all the way one full circle is a 360, isn't it? And if I take the theta out, it would be the size of this angle. Okay, so that's a 360 degrees take away theta. Okay, now you notice this now. When we actually try to find the cosine theta and sine theta in the first quadrant, we draw the right angle triangle. And then we use the SOHCAHTOA, and then we found the cosine and theta and sine theta. But when it comes to bigger than 90 degrees, obtuse angle all the way to third and fourth quadrant, we no longer use right angle triangle because it's impossible to create right angle triangle into second and third and fourth quadrant. So we are going to rely on coordinates purely. Okay, so first quadrant it was okay, but after that we are going to use coordinates. So in here, I'm just going to use coordinates here, right there. So in here is, what is it? It says minus x and y. So if I have to change it in terms of trig ratio onto the p dash, which is in second quadrant, I would say minus cos theta and sine theta. Okay? And then third quadrant, I can write it into minus cos theta and minus sine theta. Okay, this is not going to work because I don't have space, so I'm going to make it bigger. Minus cos theta and minus sine theta. Okay, that's not too bad. Now, if it's in the fourth quadrant, I'm going to say cos theta because it's a positive and negative sine theta. Okay, so we all have the coordinates, also x and y, but in terms of trig ratios. Now, one trig ratio we forgot about is a trig, the tan. Sorry, tan theta is not here. So let's have a look. So if I'm just going to put in a tan theta here, tan theta is what? Sine and cos, right? So that will be sine theta and cos theta. Okay, so that's what's going to happen. All these things will be the same. Now I'm interested in the sign of the these trig ratios. So in cosine, sine, and tan in the first quadrant, they're all positive, right? Because x and y coordinates are positive. Okay, so they're all positive here. And if I move to second quadrant, let's have a look at here. I've got negative cos theta and positive sine theta. Okay, and therefore my tan theta will be positive or negative, guys, because tan theta is a sine theta divided by cos theta, so which means positive divided by negative, which will be negative. Okay, so in second quadrant, only positive trig ratio is sine. Okay, in the third quadrant, we have negative cosine theta, negative sine theta. Now, tan theta is what? Sine theta divided by cos theta, which is negative sine theta divided by negative cos theta, which will be positive. Okay, so third quadrant, only thing is a positive is tangent, tan. Okay, and the fourth quadrant is positive cos theta, negative sine theta. Therefore, my tan theta will be positive or negative, because it will be negative divided by positive will be negative. So only thing is positive in the fourth quadrant is cosine. Okay, so that actually gives me the little diagram of, some of you might send this, it's called all station to central, or something like that if you want to. So it's all 1, 1, minus 1, minus 1, because it's a unit circle. Now, all means all three trig ratios is positive here. Sine, cos, tan, all positive. And the second quadrant, only thing is positive is sine. Okay? And then third quadrant, only thing is positive is a tangent. And the fourth quadrant is cosine. Okay? So that's what we got at this point. And also something to remember here is the first quadrant is acute angle. Okay? Whatever the points on the first quadrant, it's just acute angle, less than 90 degrees. On the second quadrant, if the point goes to the second quadrant, because we have to measure it from the first quadrant, the positive x-axis, all the way to the second quadrant, it'll be 180 minus theta, as what we did before. And then if it goes to travel to third quadrant, it'll be 180 plus theta. Okay? And if it travels, the point travels to fourth quadrant, it'll be 360 minus theta to find that angle that started from the 0 to all the way. So from 0 to, say from here is a theta, for example, and if we move to here, it'll go to here. If we move to here, it goes to here. It moves to there, it goes all the way there. Okay, so that's how you find it. All right, so that's not too bad. Now these are all introduction to trig ratios and of any angle. Okay, any angle. So we need to remember all this. Okay, so it's not too hard, but because we haven't done this before, it might be a little bit tricky for you to do things. Now let's have a look at each quadrant. Now I've got first quadrant here. Alright, my diagram is very rough. When you do it properly, please. So 1, 1, minus 1, minus 1. Okay, so if I had a point in the first quadrant, P, okay, in there. Now, my sine theta, cos theta, tan theta is all okay, okay, because we got that sorted out, okay. So everything is, that one is what? My y, that's my x, it's y over x. Now also tan is what? We can say gradient, little m. Why? Because y over x this is rise over run, isn't it? That's my rise, that's my run. So rise over run is my gradient. So tan theta is another way of saying tan theta is your gradient. Okay? So that's not too bad. So we got that sorted out. And if it was in the theta is bigger than 90, now that means P travels to second quadrant and third and fourth quadrant. Okay? So say if it traveled to here, P dash, and it's minus x and y, okay? And it was from, I'm just going to put it back, from here, okay? So it's reflected from here to gone there, okay? So that's a theta, and it's the same. Now, also, its coordinates will be x and y. Now, I want you to have a look at x and y here, and then this coordinates here, minus x and y. Now, you notice that y are the same values. Not the angle, but the value is the same, okay? And same sign as well. So, what was a y? Y in here for P is a sine theta, is my y here, isn't it? What about P dash y? P dash y is not sine theta because it's obtuse angle, which is 180 take away theta, isn't it? 180 take away theta. Anything on the second quadrant, the angle is 180 take away theta. So here is a sine 180 take away theta, and they are equal because they're same. Okay, are you okay with this? So I can rewrite this neatly. 180 take away theta equals sine theta. Okay, so that's done. But have a look at the x coordinates here. This one's the x, that's a negative x. So it's got an opposite. It's got an opposite sign, but they're reflected. So they're same. The value is the same. So I can say cos 180 take away theta is negative cos theta. Yeah, because that's different. Now, therefore, my tan theta is what? Negative. Okay, so I'm not going to write anything on that, but that's what it is. Okay, so that's okay. So that's the second quadrant. And the third quadrant, what will happen with the third quadrant? Have a look at third quadrant, guys. Third quadrant, if I put it on, P travels to here, P dash dash, and it's negative x, negative y. Now, and then theta will be the same. Now, if you look at, we'll always have to refer to original coordinate, which is the P. Okay, so refer that to the P. So when you look at the coordinates of the P dash dash and the P, that both of them in the opposite direction, like the opposite sign. So my sine, let's see, start with the cos, and anything on the third quadrant is 180 plus theta. So 180 plus theta equals, I can say minus cos theta because they're opposite sign. And then sine's the same. 180 plus theta equals minus sine. Okay, so that's what happens in the third quadrant. Well, that's not too bad. And the fourth quadrant, okay, fourth quadrant. Now, if you don't understand what I'm doing, like not 100%, please listen, pause it and listen, and then watch it again, please. So P dash dash dash. Okay, so and then that's x and minus y. Now, when I compare to with the P, I can see x coordinates the same, so which means all this fourth quadrant is 360 take away theta. So I'm going to go cos 360 take away theta equals same as cos theta. So that's okay. And then sine is different, opposite. So I'll go sine 360 take away theta equals minus sine theta. That's what happens in the fourth quadrant. That makes sense with all station 2 central, isn't it? Because in here, fourth quadrant, positive in the cos. Okay? In here, tan was positive, so the other two was negative. So that makes really sense with a lot of things. Now, we've done all this now, so I think we are all okay with this. What happens now we can do is curves, waves, sine and cosine and tan waves. So let's have a look at that. So I'm just going to draw roughly, and y and 0. Now instead of, I'm going to, well, that's like a theta, okay, x-axis is theta. So I'm just going to go 90 degrees, 180, it goes up by 90, 270, and 360. Now, use your calculator, please. Put sine curve. So we're going to go sine. So sine 0 is, if you put that in your calculator, I will get, oops, I'm just going to use some other color. Yep, 0, okay? And if you put sine 90, you will get 1. So I'm just going to do 1 here, put minus 1. Okay, so that would be 1 here. And then you put sine 180, you go back to 0. Sine 270, you will go minus 1. And sine 360, back to 0. So it is curved. So I'm not going to go poop, 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 like that. I have to go smooth curve. So I'm going to go from here and go down and curve. So it's not sharp. I thought it'll do. So you can do a little bit better with that. So you can see that that's one pattern, okay? One period, we call it, okay? And the next one will be another, same thing. And here, it'll be same thing, okay? So sine is like this. It's moving constantly like this, okay? So that's all sine curve. And cosine curve. Let's have a look at cosine curve. So I'm going to write cosine. And my axis, again, that's my y. And this is, well, let me call it a theta because it's an angle anyway. So that's a 90, that's 180 degrees, 270 degrees, 360 degrees. And if you actually do use a calculator, you will get, when you do cosine, cos 0, you will get 1. And then you put 90, you get 0. Cosine 180, you will get minus 1. Cosine 270, 0. And then 1. Cosine 360, 1. So I'm going to go smoothly, hopefully. Okay, that's one pattern here. Okay, one period. So the next one will be like this and like that. Okay, and this one like this. So that's, if you look at this, it looks very similar to sine, isn't it? Sine, what was a sine, guys? Sine was, starts from 0. Oh, forgot to not to use that. 0, and this one was 1, 0, minus 1. So if I actually sketch this, oops, shouldn't be sharpish. So it's a very similar wave, isn't it? So it's like a cosine wave is almost like it's moved 90 degrees, shifted to the left. The sine wave shift to the left. Like this is here, and that is here, that is here. So cosine wave is almost like sine waves is moved to the left by 90 degrees. Okay, that's why they're very similar. Okay, but tan is completely different. Tan is another different one. So let's have a look. So we go with tangent curve. So let's have a look. I'm going to put theta, that's y, 0, 90 degrees, 180 degrees, maybe I might need more space, 270, and 360. Okay, so when you do that, tangent tan 0 is 0, okay, and I'm going to just do something. Tan 180 is 0, tan 360 is 0. Now when you put tan 90, it will give an error. Okay, why is that? It's because tan theta is sine theta divided by cos theta, isn't it? The one thing when it's a division or fraction, one rule that we have to keep, what is it? Can't divide it by 0. Cannot divide it by 0. That means cos cannot be 0. Okay, but you know, as you saw it before, cos can be 0 at 90. Okay, 0 and 90. Oh, I've got the red one's gone. Okay, so 90 and 270 was a 0. Okay, so that means it will create asymptotes on this side. Okay, because it can't be done. So build the asymptotes there. All right, that's not too bad. Now, what's the asymptotes really? What's the characteristics of asymptotes? Somebody said the asymptotes are quite rude. What it means is it actually pulls your graph towards it, like pull, 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 but it won't let you go through it. It won't let the graph go through it or touch it. Okay, but it just pulls it. But that's all it does. So that's why it's rude. So let's have a look. So it's gonna go, and if you want to know where it is, okay, so I'm gonna do a little bit of experiment here, and so I'm gonna put like 150 here, 220, so degrees. So if you put that in your calculator, so tan 150, it'll be positive. Oh no, sorry, negative value if you put that in your calculator, and then 220 is a positive. Okay. And also, if you put maybe, I don't know, 50 degrees here, it'll go positive, okay? And then if we did minus 90, it'll go negative. And then I put, I don't know, 330 here, it'll go negative here, okay? And then positive. So what that really means, I'm just going to draw this. It'll look like this curve. It's a bit like cubic curve, but it's not. So, okay, something like that. So it's like almost like S, sort of, you know, goes down like a fall, and a waterfall. So it goes down, but it won't touch the asymptotes. Okay, so that's what you have got to do. You'll have to be careful about this. So that was our 3 curves. Now we are going to look at what kind of questions are we going to get all this, you know, information we just learned. So I'm going to put some questions in there, and that will be the end of the video. I know it's a long one, but please watch it more than once. So first question, find a theta. Now theta is acute, so that's less than 90 degrees, okay? And find theta. A, sine 130 degrees equal to sine theta, okay? So this is almost like we doing that one that we've done. Remember, sine brackets 180 take away theta, close the bracket equals sine theta, okay? Because 130 is in the second quadrant, right? Second quadrant here. That means anything on this second quadrant, we have to do 180 take away theta. Yeah, that's okay. So let's do this. So it'll be sine 180 take away something is a sine something. Now 180 take away what will make 130? So quickly think in your head, it'd be 180 take away 180 take away 130, which is 50 degrees. And that will be same as here, 50. Okay? So when I do 180 take away 50, I will get 130. So that's the same thing, and I'm just going to put it into 50. So theta, my theta, therefore, equals 50 degrees. Okay? So that's not too bad. Now, part B. Second part is tan 140 equals minus tan theta. Now that is true because in the second quadrant, because it's obtuse, second quadrant, tan is negative, remember? All station to central. So only thing is positive in the second quadrant is sine. So tan has to be negative. Now, if we got tan 180 take away, what will make 140? 40 degrees. Okay? So therefore, my minus tan is 40 degrees. So theta will be 40 degrees. Okay? So that's what it is. Now, just curious, if this was, I don't know, 300, which will be in a fourth quadrant. Okay, so it's still negative, fourth quadrant, because it's up to 270 here and 360. So 300 is in this fourth quadrant. So it'll be 10 will be 360, guys. Remember, anything in the fourth quadrant is 360 take away theta. 360 take away what will make a 300? 60. Okay? And therefore, negative 10, 60. Now, that actually, we can change it to exact form if we want to, exact value. So that will be minus root 3. And I'm going to show you why. So now it's a good time to revise the exact value of that. So I'm just going to draw this. Okay, roughly done. Okay, so I've got 30 degrees. I'm going to do 6 degrees and 45 degrees. That's the most famous exact values, and that's a sine, cos, tan. Now, watch this carefully, what I'm doing right now, and memorize it. Okay, that will be half. It's like almost like saying half plus, or I mean half plus half is 1. Okay, that's not too bad. And this, it's almost like that, but it's root 2. 1 over root 2. Okay, so it's almost like saying half plus 1, but it's not. Okay, so 45 is special. Now this one is root 3 over 2. Root 3 over 2. Now remember I said cosine wave and sine wave was very similar. It's like almost same, but it's just shifted in the other ways. So their values are similar. They're opposite. That's all. So it's opposite. Now just remember, all this denominator is 2. Okay? So if you get confused with which one goes on the top, you know that 2 is on the denominator. So the root 3 has to be on a numerator. So that's what it is. Now 30 and 60, 10 here. Now 60 is the bigger, and it's root 3. So remember, root 3, and here is 1 over root 3. Okay, 30. So 30 is smaller than 60. So therefore the value is 1 over root 3. That's how I remember. And then 60 is bigger, root 3. So these are the exact value of trig ratios of 30, 60, 45. Okay, so knowing all this, I'm going to do the question on finding exact values. So I've got some questions here and I'm just going to do it. So we're going to find the exact value of each expression. So A, I've got sine 120 degrees. Now, we can't find 120 exact value because we know 30, 60, 45. So we need to change this one into 30 or 60 or 45. How are we going to do that? Now, remember, this is the second quadrant, isn't it? This is the second quadrant. What's the formula for second quadrant value we're going to find? 180 minus theta. Okay, so let's do that. Sine equals 180 minus what will make 120? Now quickly you do this in your head. 180 take 120. That will be 60. So I've got 60. So therefore I can say sine 60 is the same. Okay, so that's okay. Now what was a sine 60 in the graph? Table we just did? It was root 3 over 2. Okay, so that's done. B, and tan 135. So what's that? Tan 180 take away 45, because I just did 180 take 135, it's a 45. And that means same as tan 45, which is 1. Okay? And then previous question was tan 300. So that means it's in the fourth quadrant. So tan 360 take away 60. That means a tan 60, which is root 3. So that's how you do it. Okay? Well done, people. That was long. Okay? But make sure you watch it again, and make sure you understand. All right? Great. Thanks.